Now we are going to take up one more problem on projections of lamina. How to solve this problem number 97 by how to analyze this problem, that is problem number 97, and also how to do it by the manual sketching. So first we will read this problem. A pentagonal lamina of sides 25 mm is having a side on both HP and VP. The surface of the lamina is inclined at 60 degrees with HP. Draw the top and front views of the lamina. So the problem can be split as he says a pentagonal lamina of side 25 mm is having a side on HP. So he says since it is on HP, so obviously we have to start from HP. And he is also saying that a side is resting on HP. So make that side perpendicular to VP. So we can see that the side AE is made perpendicular to VP and the surface of the lamina is inclined to HP. So obviously the surface is made parallel to HP. Since the surface is parallel to HP, so we are getting the true shape in HP. Now as we see, when you look from the top view, ABCDE is the sides of 25 mm, which is in true length, because this is the true length in the horizontal plane. Obviously the lines are parallel to HP. Since the lines, that is A dash B dash, B dash C dash, C dash D dash, D dash E dash and D dash A dash, all the 5 sides are parallel to HP, so we are getting the true length. And as we see from the front view, ABC is near to the observer, so A dash B dash C dash is visible, and D and E is away from the observer, so obviously D dash and E dash is in bracket. So the surface is parallel to HP and perpendicular to VP. Since it is perpendicular to VP, so that is the surface is 90 degrees to VP, so obviously you're getting a line in the vertical plane. So this is the orthographic view of the first position, wherein the side is perpendicular to VP and we have drawn a pentagon of ABCDE. As we see from the front view, ABC is near to the observer, so A dash B dash C dash is visible, and D and E is away from the observer, so D dash and E dash is in bracket. Now, since the surface is parallel to HP, the surface inclination with respect to HP is 0 degrees. So, and it is perpendicular to VP. As the perpendicular to VP, it is a line in the vertical plane. And since it is parallel, you are getting a true shape in the horizontal plane. Now, in the next position, he says a pentagonal lamina of sides on HP, the surface of the lamina is inclined at 60 degrees to HP now. So as we see here, as we rotate the initial position by rotating at an angle of 60 degrees, in the second position what happens, the surface is inclined to HP, but still the surface is perpendicular to VP. You can see it is perpendicular to VP, so that is the reason why we are getting a line here in the vertical plane. And as he says, the side is on HP, AE is the side which is resting on HP. When you look from the front view, ABC is near to the observer, so A dash B dash C dash is visible, and D and E is away from the observer, so D dash and E dash is in bracket now. But EE is the side which is parallel to HP. Since it is parallel to HP, you are getting a true length in HP, it is EE. And also we can see it is perpendicular to VP, obviously you are getting a point in the vertical plane. So, and since A dash E dash is on XY line, obviously that AE is in the horizontal plane. And we can see here, this initial position is rotated by an angle of 60 degrees, so that A dash E dash is the side which is resting on HP and all other sides are above HP and all other points are also above the horizontal plane, which is also evident from 3D sketch, but also it is evident in the 2-dimensional sketch. And to this we write the corresponding top view, and in the top view we have not given the horizontal plane, we have not shown the top view to have the better will not be having the better clarity, so that is the reason why we have not shown the top view here, but here we have shown the top view. Here A dash B dash, B dash C dash, C dash D dash and D dash E dash, all the sides are inclined to HP, so AB, BC, CD, DE are in apparent length, and A dash E dash is the line which is parallel to HP, so you are getting the true length in HP, and since it is perpendicular to VP, so you are getting a point here. A dash E dash is on the horizontal plane. Now, in the next position, a pentagonal lamina having a side is on both HP and VP. So since it is the side is resting on both HP and VP, the side which is resting on HP is now perpendicular to VP. You make that side you make that side also on VP. So what we have to do is, in the second position what we have shown, in the second position what we have rotated, and then you rotate again by an angle of 90 degrees such that you AE you keep it on the vertical plane. So to do that, you keep the AE on the vertical plane also, and when you rotate, still the surface is inclined to HP at 60 degrees, and to write the corresponding top view and to write the corresponding front view, we have not shown the corresponding front view here to have, will not be able to have the better clarity. So that is the reason why we have not shown here, but you can show here, so that when you are rotated this, the second position top view by rotated by an angle of 90 degrees such that keep AE on the vertical plane. In this condition, the line AE is parallel to HP and perpendicular to VP. Since you want that AE also on VP, you rotate the second position top view by an angle of 90 degrees in the clockwise direction such that you keep it on XY line in the top view. So once you do that, to write the corresponding front view, so this will going to be the shape where you are going to get the front view in the third position. Now we will see how to solve this problem by using the sketchbook. So first you draw a XY thin line by thin line, and you mark XY and VP and HP. And as it says, a pentagonal lamina of 25 mm side, you take 25 mm, you measure 25 mm in the sketchbook and draw a vertical line, and you mark this point as A and E with a dot line. So by using the protractor with A as center with respect to the line AE, you measure an angle of 108 degree, include the angle from EE, and draw this inclined line. Similarly, with A as center with respect to the line AE, measure an angle of 108 degree, again it is the included angle, and then draw an inclined line. By using the compass with A as center, taking the radius at 25, cut on this 25 degree 108 degree line, and also with E as center, cut on this 108 degree line. So you are going to get the point B and D, and you mark those points as B and D. With B as center, taking the radius of 25, draw an arc, and similarly with D as center, cut on the previously drawn arc, so that you are going to get the point C, and you mark the point as C. Then join A to B, B to C, C to D, and D to E with a dot line. Then you draw the front view. So to do that, you draw a vertical thin projector from EE to the XY line, and also from B and D to the XY line, and also from C to the XY line. Then as you see from the front view, ABC is near to the observer, so you mark this point as A dash, B dash, and C dash without bracket. And as we see, D and E is away from the observer, so D dash and E dash in bracket. Then join. As we have joined between A to B and B to C, similarly you join between A dash and B dash with a dot line, and B dash to C dash with a dot line. Then we have to write the second position front view. So as you see, one of the sides is resting on HP. The side which is perpendicular to VP is the one which will go to rest on HP. So you mark that A dash, E dash. Take any convenient distance from the first position front view, and you mark that point as A dash and E dash in bracket. Then by using the protractor with A dash, E dash as center, measure an angle of 60 degrees and draw an inclined line. Again with A dash, by using the compass with A dash as center, taking the radius of A dash, E dash on the first position front view, and transfer it from A dash, E dash in the second position front view, and cut an arc on that 60 degree line, and you mark this point as C dash. Similarly with A dash as center, taking the radius of A dash, B dash with A dash as center, cut an arc on that 60 degree line, and you mark that point as B dash and D dash in bracket. Then join A dash to C dash with a dot line. So once you get this, now we need to write the corresponding top view. So draw a vertical projector from A dash and E dash to the top view, and draw a horizontal projector from A and E. Both these two lines will going to intersect at this point and also at this point, and you mark this point as small a and small e. Similarly, draw a vertical thin projector from B dash and D dash, and draw a horizontal thin projector from B and D. Both these 2 points will going to intersect at the second position top view of B and also on D, and you mark this point as B and D. Similarly, draw a vertical projector from C dash and draw a horizontal projector from C of the first position top view, and these two lines will going to intersect at this point, and you mark this point as C. Then join A to B, B to C, C to D, and D to E, and E to A with a dot line, so that you are going to get the second position top view. Now you have to write the third position top view. As he says, is a side is on both HP and VP. One side is already resting on HP, and the same side has to rest on VP. As we can see, AE is perpendicular to VP. You rewrite the second position top view such that AE should lie on the vertical on the XY line. So by using the compass, you measure the distance from A to E. We consider any distance from the second position front view, and you mark that point on the XY line. And then you mark this point as A and E. You have to rotate in clockwise direction. You measure the distance from A to this point and also transfer it from A to this point, and draw a vertical perpendicular line from the XY line. It should be a thin line to the top view. Then from this point to the distance C, you measure the distance by using the compass and transfer it from this point towards C here, and you mark this point as C. Then measure the distance from this point to this line here, to this point, transfer it from here to this point. Then draw a horizontal line perpendicular to this vertical line, and then you measure the distance from this point to B and also from this point to D. Both will going to have the equal distances, and transfer from this point towards the left side, and you mark this point as B, and from this point towards the right side, you mark this point as D. Then join A to B, B to C, C to D, D to E, and E to A with a dot line. So this is how we will be able to rewrite this second position top view in the third position. Then once you do that, as we draw a horizontal projector from A dash and D dash, and AE are on the XY line, so you mark this point as A dash and D dash. Similarly, draw a vertical projector from B, vertical thin projector from B and D to the front view, and draw a horizontal projector from B dash and D dash. Both these 2 points will going to intersect at this point, and you mark this point as B dash, and you mark this point as D dash. Similarly, draw a vertical projector from C and draw a horizontal projector from C dash. Both these 2 points, both these 2 lines will going to intersect at this point, and you mark this point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and E dash to A dash with a dot line, and show the dimensions accordingly. Whatever the dimensions which is given in the drawing, you show that he has given a pentagonal lamina of 25 mm sides, such that a side is on both HP and also on VP, and the surface makes an angle of 60 degrees with HP. So this is how you will be able to analyze and solve the problem by using the sketchbook. Thank you.